Dear students, in this video we are going to learn new concepts. One, what is the meaning of dihedral angle and how it affects the stability of different conformations. Second, we are going to see various types of the strains present in molecules. For example, torsional strain, steric strain, and angle strain. So these are the different concepts which we are going to discuss. Let's start all this by taking the example of ethane molecule. So this is ethane molecule shown here. This is the carbon-carbon bond. These are two carbons. They are connected to three hydrogens. Both the red as well as the blue balls, they represent hydrogens. It is just for the sake of simplicity or sake of clarity of our distinction that I have given them different colors so that I can distinguish between the front carbon and the back carbon. Now, if I look from this side, along the carbon-carbon bond, then this carbon would be the front carbon and that would be the back carbon, and the molecule would look like from this side like this. It is quite evident from this picture that the front hydrogens are completely eclipsing the back hydrogens. So this conformation or this spatial arrangement of ethane molecule is called eclipsed conformation. The drawing which we use to depict these, that's called Newman projection, in which the front carbon is represented with a dot while the back carbon is represented with a circle. So the carbon-carbon bond is kind of, you can say that it is squeezed, and this is how it is represented. So you have three hydrogens and three at the back which are completely eclipsed. So they are completely eclipsed by the front ones, right? So front ones are red and the back ones are blue. Right? So this conformation is called eclipsed conformation of ethane, right? Now, you know that in conformational isomerism, what happens is that you rotate the molecule along the carbon-carbon bond, like you rotate it from here, like this, you rotate it, keeping one of them constant. Generally, we keep the front one constant, but you can use the other way as well. So if I rotate now, this is the eclipsed conformation. If I rotate the front one by say 60 degrees, so this hydrogen will come here. This hydrogen will subsequently go to this place and this one will go to this place. And that is what we observed. I have depicted that in the next picture. So if I minimize this, so this will come here, which I can see. This will go here, which I'm seeing here, right? And this will come here, which I'm seeing here. So this conformation or this spatial arrangement is called staggered conformation. Back carbon, front carbon. So front carbon has moved and it is now like this. The back is like this, right? So this is front one and that one is back one. This is called staggered conformation. Staggered conformation. I've recorded a complete video on this, which you can watch on the channel. Staggered conformation. Now, of the eclipsed as well as the staggered conformation is more stable, and in a sample of ethane gas, almost 99% of the molecules, they adopt this conformation. That is, they exist in this conformation as compared to that one. And that too, so it's not like they are fixed or something. The carbon-carbon bond is free to rotate at room temperature. So they're continuously changing their conformations. But at any given time, most of the molecules, they are in the staggered conformation. What's the reason behind this? So in this case, since they are in the same space, so there's kind of some strain here. some tension here, which is not in the case of staggered. What is the difference between these two? The difference is of the dihedral angle. Here the dihedral angle, if I talk about this position, so the dihedral angle between these two is 0 degrees, while in this case the dihedral angle is 60 degrees. And the smaller the dihedral angle, the more is the torsional strain. Now, these two terms are new to you. What's the meaning of dihedral angle? And what is the meaning of torsional strain? For this, let's see first understand what is dihedral angle. Now, to define any angle, you know that you need at least 3 points, A, B, C. So, you're talking about this angle, and to define this angle, you need 3 points. But in case of dihedral angles, you need 4 points to define an angle. Okay, so if I take the example, like if I have a molecule which is like A, B, C, and D. Okay, and if there is a plane that cuts A, B, and C, okay, so if these 3 points they define, and there is a plane which is like this. Now the angle between these two, which is this plane and the one in the green at the back, that angle is called dihedral angle. So if you can see, it looks like a half open book. So it's exactly like that. So the angle, or it's like a half open door. Okay, so that angle between the hinge and the door, that is the dihedral angle, right? So depending upon if the book is totally closed, that angle is 0 degrees. If the book is like you open it from the half and put both the halves on the table, okay, in the open mode, then it is 180 degrees. So this angle is the dihedral angle, right? It is between two planes, and it involves 4 points, and those 4 points should be connected in a row. That's the condition. The 4 points should be connected in a row. So the angle between two planes formed by 4 groups or atoms which are connected in a row, that's called dihedral angle. So in case of ethane, so this is one plane, this is another plane. Okay, so the angle between these two planes, that is called dihedral angle, which we can see here. So this is one plane, this is ethane molecule. If you see clearly, this is ethane molecule, right? So there's one carbon, there's another carbon, there's a carbon-carbon bond, and then there are 3 hydrogens on each of them. So the angle between this plane and this plane, that is the dihedral angle, right? Now we'll talk about different strains. As we said that here the dihedral angle is 0 degrees, more torsional strain. Here it is 60 degree, less torsional strain. So it is more stable conformation. So molecule will prefer to stay in this state, right? Now coming to torsional strain. So in general, the molecules tend to be in a relaxed position, because in that position they would not have any strain, their energy would be minimum, their stability would be maximum. But under certain conditions, the molecules are forced to have some strain, and because of which their energy increases and their stability decreases, and they tend to undergo some reactions. Now, depending upon the reason for that strain, there are different types of the strain. Torsional strain. To understand torsional strain, you can think about those like wind-up toys in which you have a spring in them, and when you use that key to wind that up, so the energy gets stored in that spring, and as soon as you release that, the toy starts moving or working in that condition. On similar lines, due to certain reason, when the molecule is twisted or rotated around a certain bond, its energy gets increased, and that energy is called torsional energy, right? So, and because of it, the molecule becomes unstable. This energy is highest when the dihedral angle is 0 degrees. Most of the time this happens when you have an eclipsed conformation, right? Torsional strain, now what's the reason for the torsional strain? I understand that molecule gets twisted, but why it gets twisted? It gets twisted because when the two groups or the atoms, they come close to each other, beyond a certain point, their electron clouds, they start repelling each other. They start repelling each other because they have the same charge, so their electron clouds, they start repelling each other, and because of which they develop the torsional strain. Now, important point here is that for a molecule to experience the torsional strain, so the electron clouds of the two atoms where we are expecting a torsional strain, they should be separated by 3 bonds only, neither more nor less. 1 bond, 2 bond, 3 bond. So the kind of strain between these two hydrogens, that is torsional strain, and it is maximum when they are in the eclipsing conformation, as in the case of eclipsed conformation of ethane, when the dihedral angle is 0 degrees. So the hydrogens are quite close, their electron cloud starts repelling, and that's what torsional strain is, right? Now here the important thing is that they should be exactly 3 bonds apart. So this is the molecule of cyclohexane having 6 carbons. So most of the time it adopts this conformation, which is called chair conformation of cyclohexane, which we will discuss in detail. At this point, you can just think of it as if this molecule, it adopts this type of the shape. Okay, so 1 2 3 4 5 6, so 6 carbons, they adopt this conformation. Now if you focus on the green one and the red one, their electron clouds seems to be quite close to each other, so they should repel. So what type of strain can it be categorized as torsional strain? So let's see whether they are 3 bonds apart, 1 bond, 2 bond, 3 bond, 4 bond. So this type of strain between the red and the green hydrogen, that's not called torsional strain because it doesn't qualify for the 3 bond thing, right? Now let's focus on the red one and the yellow one. So 1 bond, 2 bonds. So this is also not the torsional strain, right? So this is how you can see whether the type of the strain between the two hydrogens is torsional or certain other type of the strain. Second type of the strain is steric strain. Steric strain is like when the two atoms, they come quite close to each other in space. They are quite close to each other, actually like bumping into each other, or they come close to each other more than their van der Waals radii, right? If this is one atom actually, and this is the other one, and they come more close to each other, like what their ideal distance should be. So that type of the strain is called steric strain. Its magnitude is always more than the torsional strain. Okay, it doesn't require any specific number of bonds separating, and the energy cost associated with the steric strain is much bigger than the torsional strain, right? Now let's try to understand this steric strain. So this is the ethane molecule. So this is one of the hydrogens, the other hydrogen, suppose in the eclipsed conformation, but still this strain is torsional, not the steric, right? If I replace this hydrogen with fluorine, which is much bigger in size, so obviously its electron cloud would be more spread out, okay, as compared to hydrogen because it's bigger in size, based on size. Still, this is torsional strain, 3 bonds apart. So this type of the strain or the repulsions between the electron clouds can be categorized as torsional strain. Now if I replace this hydrogen also with fluorine, now their electron clouds kind of interpenetrate into each other. So because of this interpenetration, the type of the strain which is developed, that is categorized as steric strain. So it's actually they're bumping into each other. It's not like they have an influence on each other. Here there was an influence on each other, so torsional. But this one is steric. So this strain is steric strain. Got it? Now the third type of strain, angle strain. To understand angle strain, we will take the example of propane molecule, right? So this is propane, CH3, CH2, CH3. So this is CH3, CH2 and CH3, right? So you can see that this bond is quite straight. This is also straight. Now, if I have to make cyclopropane, from propane I'm going to cyclopropane, which is a cyclic molecule. So when I try to connect this bond, this carbon with a bond, you can see that how my bonds, they get curved, they develop a kind of tension in them, right? Can you see that? And it happens, it's not like I force them. As soon as I try to connect this one with this one, the whole molecule develops a kind of strain, and this type of the strain is called angle strain. Okay, now why is it so? In order to understand this, so you have to imagine the kind of ceiling fan or something. So if you have a ceiling fan, say, and this is the central motor or the central plate of the ceiling fan, right? And I ask you to attach two blades or the wings to this ceiling fan. Would you arrange them like this, or would you arrange them like this? I believe that you will go for this one, since the repulsions or the distance here between the two blades is quite large. So the fan in this state would be more stable as compared to in this state, because the whole weight would be on this side. So stability would be less, right? Now, if I ask you that you have a central plate, right, for the fan, ceiling fan. So this is the central plate, right? And I give you three blades and I ask you that you arrange them. Are you going to go like this, or would you go like this? As per my understanding, you will go for this one. Why? Because this is the more stable arrangement of the three things around the circle, and the angle between these two blades through the center is 120 degrees, right? On similar lines, if I ask you to arrange four blades around a central plate, so this is the central plate, and you have to arrange four blades around it. So you would probably by now you know the things, so you will say that they will be arranged like this, and that's true. They should be at 90 degrees to each other, right? But this is the scenario when you are working in 2D, two-dimensional thing, or in the planar way. If the things are planar, then they would be like this. However, in chemistry, in the molecules, they have three-dimensional, arrangement around the central thing. So when you do that in 3D, you can try this by taking the clay dough and the toothpicks. So the only possible arrangement which is more stable or the most stable would be when your four blades, they are in three dimensions. So when they are 109 degree 28 minutes from each other, that is the angle between them is 109 degree 28 minutes, right? So when you have a carbon and four hydrogens around it, so the angle, which is the ideal angle between HCH, that is 109 degree 28 minutes, and any angle lesser than this, that would be the cause of the strain in the molecule. So here what is happening, that this is the carbon, these are the two hydrogens, but the angle, if you see here, that's not 109 degree, that's very much like, that's a kind of acute angle. And because of that, because you pushed a thing which should be ideally at an angle of 109 degree in 28 minutes, but because you want to make a geometry which is like a triangular thing, so it's like you pushed that, like there is a geometrical strain, which is, the geometry is actually giving it as an angle strain. And because of which the molecule becomes unstable and wants to open up. And that's why cyclopropane is very reactive. Why it is very reactive? Because there's lots of angle strain and want to get rid of that strain. Okay. And the way to get rid of that is to react with something else. And yeah, that's it. So that's all about dihedral angle, torsional strain, steric strain, and angle strain. And I hope the things are quite clear to you after this listening to this lecture. If you like my content, please do subscribe to my channel so that I keep on recording more and more videos on organic chemistry or in chemistry in general. Thank you very much.